All right, here we go. We're going to start chapter 3 right now, which is starting by talking about the domain and range of functions. There's a lot of words in this first section, a lot of definitions, a lot of ways of looking at different ways of looking at things, but we're going to try to simplify the whole process. The end goal today would be that you would be able to determine whether relations or sets of data or graphs are what's called functions. So there's a bunch of words in this section in vocabulary. So you're going to take a minute on the next slide and just pause the video as we're going so that you can get all the definitions down and understand each part along the way. The first definition we're going to talk through is what's the domain. The domain in a function is really just what are the x values. So if you were to write down a condensed version of this definition, I would just write down that the domain is the x values. Done. Some other times it might be called the input values. So maybe add that one in there as well. The range value is different. The range is the opposite. So the range sometimes we call the outputs or we call them the y values. In order for something to be called a function, every input or every x value can only have exactly one output. So in order for something to be called a function, this whole thing would need to be written down. Each input, right? Inputs are the x values. Each input has to have exactly one y value or one output value. One of the ways that I like thinking about these things as functions, I like to say, does your x value ever repeat? And x cannot repeat. You might want to add that. X can't repeat. If your x value repeats, then it's no longer a function. Your next definition is what's called continuous, and then the next one is discrete. And these are kind of like opposites of each other. So the domain of a function is continuous if it includes all the real numbers, meaning it can be a fractional value, it can be a decimal value, as you're working through those, is a continuous function. And then a discrete is if it doesn't include all of those fractional pieces. So if it's including just like whole number things, then it would be considered a discrete function. If you can like think about filling up a car with gas, that would be continuous because you can fill up a car with a half a gallon or a quarter of a gallon or 0.1 of a gallon of gas. Now that we know all of these main definitions, for the domain and the range and whether things are functions are the most common worded ones throughout this whole chapter. We'll talk a little bit about continuous and a little bit about discrete as we go. There's one other definition that we'll talk about in a few minutes. It's this one-to-one definition. Okay, so the first thing that you're going to be asked to do today is just be able to list the domains and the ranges. If you have a domain and range like this on a table, right, sometimes you're going to be given a table, sometimes you're going to be given a list of ordered pairs. You just have to be able to list the domain, and you need to remember that the domain values are your x values, and your range values are your y values. So as we are working through and listing them, right, the x values, you're just going to list the values out. If things repeat, you only want to list them once. So if we were to list our domain values, it'd be the values, the numbers 1 through 5, right? And we put them in with commas in between. You list them with these fancy curly brackets. That just sets up your set of domain values. And then when you're listing your range values, because the 13 repeats, you really just want to list one of each that are listed there. We usually like to list them when they're in numerical order, right? 11, and then 12, and then 13. So when you're listing a set of domains and ranges, right? So you're going to be sometimes given a chart, sometimes you'll be given a graph. Your domain, you're trying to find what are the x values, and the ranges, remember, are your y values as you're listing those points. So take a second, copy down these two tables, pause the video, and then list out your domain values and list out your range values for each. Okay, so did you get that the domain values for the first table would have been the 2, 3, 4, 5, and 6, And then your range values for this first one are the values 0, 1, 2, 3, and 4, right? If we were to list out my domain values on this one, right, domain values, we list them with those curly brackets. I would list the -3, the -1, the 1, the 3, and the 4. And my range values, we usually list them in numerical order. So I'm going to list it as -2, and then 1, and then 2, and then 3, and then 6. Right, so that lists all of my y values, domain range values, lists all of my x values, my domain values. All right, so x is our domains, ranges are y. Okay, so for example number 2, I don't really think you need to write anything down. I think if you're just listening to this concept, I think it's going to make some good sense to you. And then we're going to work through the next example, which is what more of the homework is going to come from. So a function can model a situation, and then what we're going to look at is what is a reasonable domain and range for each function. So if these are two separate stories, two separate problems that we're working through. So we're going to focus first on the one on the left, and then we'll focus the one on the right. If a hose can fill a 10,000-gallon swimming pool at a rate of 10 gallons per minute. If we're talking about what's the reasonable domain, the domain could be starting at 0 minutes and then all the way up until however long it takes you to fill the pool. So the domain would be the time that it takes starting with 0. So to my domain value, right, and we could have a half a minute, so it'd be the values domains anywhere from 0 and above, which would be all the real numbers, 0 and above. And then your reasonable range values, right, need to go from the 0 up until that 10,000 gallons that can fit in that pool. And remember, you can have fractional values. So it's not just the 1 gallon, 2 gallon, 3 gallons, right? It can have a half of a gallon or a quarter of a gallon as you're filling them up. So then that would make, I'm going to focus on this left-hand side, us to have a continuous volume in our pool, right? So we could take our time in 1.5, you could take your time at 5.5, right? And you could have the volume of the pool having a fractional amount of water and not just whole numbers as you're working through the amounts in the pool. The opposite for the second example, right? If a restaurant needs to order chairs for its tables and one table can have 4 chairs at it. So if we're talking about the domain would be from having 0 tables up to however many tables can fit in the room. And the range would be how many chairs you're going to need for each table. And if each table can have 4, the range would be in those multiples of 4, since 4 chairs are fitting at each table. So for 1 table, we have 4 chairs. For 2 tables, we have 8 chairs, right? So this makes that a discrete function because it doesn't include, we don't have a fractional amount of tables that we're going to buy, right? You can't buy 3.5 tables. We can only buy the whole number of tables. Okay, so once that makes sense, we're going to move on to the last part of today, which is big parts of today is, can you just list out domains and ranges? And then the second big part of today is, can you know whether things are called what's called one-to-one? Okay, so for example number 3, we're testing whether these things are called functions. If it is a function, is it one-to-one or not one-to-one? Which we'll talk about that in just a second. So in order to tell whether something is one-to-one, no 2 elements of the domain can map to the same element in the range. Okay, so a function is one-to-one if no 2 elements of the domain can map to the same element in the range. So if we look at a set of data, ordered pairs like this, 1 and 2, right, that ordered pair, 5, 6, 7 and -1, and 8 and 0 as a set. Notice the curly brackets around the whole set, and each individual ordered pair is listed as the x, comma, y point, with a comma in between. So yes, it looks like there's a bunch of commas. As we're working through and understanding this one-to-one business, right? This relationship would be a function because each x value that you have in here has a different y value that is associated with it. So because every element in the domain, 1, 3, 5, and 7, has one range value that goes with it, then it's considered a one-to-one function because no x values, no y values repeat. When you are checking whether things are functions or not, really what we're looking at is you're trying to find that each input has exactly one output, which sometimes is a little bit tricky for kids' brains to understand. So sometimes it's easier, I have found, to just see, do your x values ever repeat? So when we look at this second one, example of number 3, right? So this first one is just when it's listed as a set of ordered pairs, right? No x values repeat, 1, 5, 7, and 8. So then it is a function, right? And it's considered one-to-one because no x's, no y's repeat. When we look at this graph as a function, we are going to talk about what's called the vertical line test. So what the vertical line test does is it says if you were to draw a million vertical lines, now are we really going to draw a million? No. But if we were to draw a million vertical lines on our graph, the most amount of points that it can cross in our graph is 1. So when I draw a vertical line here, it only touches, right, that one data point. It can never touch more than 1. So if I draw if it doesn't touch any, then we're good, right? Don't mind that I have squiggly lines drawn, right? If you were to ever cross twice, then it is not going to be a function because it doesn't pass what's called the vertical line test. So in order for something to be a function, we either want to answer the questions like this: does any of the x values repeat? If you have a graph, I think it's easier to see if you were to draw any vertical lines on your graph, do any vertical lines touch more than once? Because if they do touch more than once, then it's not a function. So if we were to take a second and think about another graph, right? So if I had a graph like this, and I was talking about a graphed line that looks like this, and then I were to say, is this going to be a function? Yes or no? But if we were to draw a vertical line right here, it crosses twice. So as soon as something crosses twice, then it's not a function. Right? So it's kind of two big parts to today. One part is, can you just list domains and ranges? That's the main part of today. Can you list domains and ranges on your graph? And then after you're listing your domains and your ranges, your second thing is, can you tell whether things are functions or not? So if we look at this, this is called a mapping on the left-hand side. So this mapping is talking about the values when x is -2 and your y is 5. So I have the x value of -2, the y value is 5 for that first one, right? If we're listing a set of ordered pairs. My second set is when x is 3 and y is 6. My x is 3 and y is 7. My x is 4 and my y is 8. Because this x value repeats, 3, 6, and 3, 7, then this one would not be a function because that x value of 3 is repeating. If we were to talk about a graph, right, this graph value, if we were to draw a million vertical lines up and down on this graph, since nothing ever repeats itself, then this one would be a function because no vertical line ever would touch twice. So two real big parts today. One is, can you just list domains and ranges? The second big part is, can you tell whether these things are functions? And there's really kind of two ways of telling. The easiest ways are vertical line tests when you have graphs. And then the second way is checking on any of those x values repeating. Because if they are repeating, then it's not a function. Okay, so you're going to work through your assignment today, and when you work through your assignment, today's assignment, you don't really need to write anything down on your paper. I'm okay with you working through the questions. Because there's a lot of is it a function or not? It's just a simple yes or no. You only get one shot at it. So just make sure you're walking through slowly and understanding that each function, right, can only be a function if the vertical lines never touch twice or more, and then are your x values repeating. Okay, we'll check back in again on Wednesday to make sure everything's solid with these before we move on to section 3-2.